All right, happy Monday. So, a couple things today. Let's take a look and see what's on schedule. If we can get the website to load. There it goes. All right, so we're moving on to all things strings. Lots of fun with strings. Um, a lot of cool things we can do with strings. This is not my favorite chapter. Um, Mostly like know that you can do all these cool things, and then we're cool. But we'll practice some of them, have a little bit of fun here. So that's our Zybooks. Pull that one up and take a look at our strings chapter. So there's only like four sections here, so I'm gonna turn on these ones here. Sorry. Uh, Integers and names and counting characters. This one's fun. Counting characters is great. Come on, load. No, load. It didn't load. Did I? No, that is visible. Okay, what was it doing here? Visible? I think the website's just screwing up here. There we go. Mad Libs. Mad Libs are lots of fun here. Palindromes. And last one here. Lots of practice for these. Okay, so it'll be a little shorter this week, which should be nice. You'll have a little more practice for a little more time for working on the Hangman project. Hopefully that's going well for you. Everyone loves playing Hangman, even though it's a little weird that this is a game we teach children. You're like, hey, go hang this person. Uh, yeah, that's weird. Also, because America is stupid, we celebrate Columbus Day today. He did not find America, or at least he did not find the country that we now call the United States of America. So we celebrate him anyway. So I don't know if you celebrate. Maybe we could celebrate Indigenous Peoples Day because people already lived here before Columbus didn't find the United States of America. So sure, that's a whole other story. Okay, so strings. So we've done a little bit of this string slicing bit here, where we said, "Oh, that's Visual Studio. You want PyCharm? We try that." And I got to clone our repository. This is brand new. Super excited. CS 1501. Fall 2023. Let me clone this repository here so we can get moving. There we go. It's all new on this laptop. And this is why GitHub is great, right? Everything's just here now. All right. Yes, I installed it. I didn't actually go and run it yet. I installed it. New project. Go change this folder right to my documents, GitHub. Their browse is like the worst browse ever. What? Did it move it? It moved it. I don't want it in my OneDrive. Okay. That's the wrong spot here. I will have to move that later. That's sad, but sure. Okay, we'll call this one then. This is chapter 7 strings. Using my Python interpreter. Fantastic. Cool. Make all that. So we've gotten one character out at a time with strings, right? We said, hey, given a string, we can use that square braces and say, give me a character at a specific index, right? So I said, hey, name with Eric. Oh, that's really small here. So, well, zoom's not set. All right, hang on. Where's my zoom? Zoom. I want the key bindings, right? For zooming, zoom in the IDE. Is that what I want? I don't want the window zoom. Control minus. I don't want to zoom images. Fit zoom. It was like, is it clear advanced? Change. Okay, there we go. Change font size with control mouse wheel. There we go. That's the one I want. Okay, now it zooms for me. That's much nicer. Is that better? Super large? Maybe a little bit less? Anyway, so we said, hey, like initial then could be name index of 0, right? So index of says, go give me the character at this index, right? Or we could loop through. We could say for index in range length of name, right? We did ranging over the length of the name will give me indexes 0, 1, 2, and 3 because Eric has 4 letters in it. There is no index 4 in Eric. right? So then maybe I wanted to say, how about we print to upper uh, name at index dot upper. There we go. So we'll uppercase everything, and then we'll change that ending character to nothing. So one letter at a time we can uppercase it, which is kind of silly because we can uppercase the whole string at once. But if we wanted, no. Or how about we said, hey, if index is equal to 0, then we'll print the uppercase letter, else we'll just print the regular letter. Maybe we'll force it to lower. So I will specifically capitalize the E in Eric and make the rest of them lowercase, right? So if I was typing something really silly here and did it backwards, it should print out like we'd expect a name to print out, right, with a capital letter. That one's kind of fun, right? So we can do things one character at a time. Turns out you can do more than one character at a time. You can get an entire slice. So this is technically a slice. It's just one letter sliced. Uh, you can get more than one character at a time, which is fun. So you can say, hey, give me from the starting index to the ending index. So if I want 0 to 3, I'll get the first 3 letters. So you don't get the end, right? So I don't get 3. Just like when you range, you don't get the last value. So 0:3 gives me index 0, index 1, and index 2. Doesn't give you 3. So it takes a slice of this here. So we can go and say, okay, maybe I put my whole name in here. So this was Eric Charnesky. And that'll be a little silly later here, but that's okay. So if I wanted just my last name, so last name, hold this down here, sorry. Last name is equal to, so it's name, and then I want to slice. So this is index 0, 1, 2, 3, 4, 5. So I want to start at index 5, and I want to go to, how about the length of name, right? Start at 5, go to, I don't know, whatever the length of name is, right? That'll be the end. That'll be the last character it slices. And there is no 15 here, right? 14, right? 9 plus 5, 14. There is no 14 here, so it'll stop at index 13. So if I print last name, should get just Charnesky back out. Yep. Look at that, it found it. So we're able to slice. So you can get more than one character at a time as you're working with strings. Now, what's fun is they're optional. Where's it? So if you don't give it an end, it assumes you want the end. So if you don't say stop at a specific index, it just goes to the end of the string. If you don't give it a starting index, it starts at the beginning of the string. It says, oh, you probably want from the beginning. You can also give it negative notation, which is fun. You're like, hey, -1 character from the back, or -5 characters from the back. It gets to be a little weird, but you can read like that. So, PyCharm, there we go. So if I wanted just a couple characters, let's see, so we could have first name is equal to name. So the start is optional, and I know Charnesky is 9 letters. So if I say -10, -9, I think that'll work here. Let me print first name, see if I get it right. It should be up to 9 characters back. I think I want the 10th one. Let's see. Yeah, it printed a space, so I do want 10. So when you go negative, right, it stops at that character. So this is -10 back, is this location. And it stops here. It doesn't give me the space. Because I know my last name has 9 letters in it. So you can do negative if you want. So this is negative counts in from the end. Does that counting in from the end? Does that make sense? Saying it that way? The ending index is optional. Defaults to the end of the string. So going to the length of something is redundant because you could just take that out, right? It's the same as saying last name equal to name sliced 5 colon, right? Does the exact same thing here. This length of name versus just slicing to the end here because that is an optional one here, right? And then start is also optional. Start index defaults to 0. So remember when we wrote functions, you could give default values. Think of it sort of like that. Imagine it was a function where the start defaulted to 0, the end defaulted to the length of the string. So we've got some options as we're doing it here when we use those. You can also have a stride, like you can range, and you can say, hey, I want to range by 2 and count every 2 numbers. You can do that when you slice. You can take every 2 characters, every 3 characters, every 4 characters. I don't know why you'd want to, but you can. So if we were to have like the alphabet, let's come down here to the end. Let's say here's the alphabet. It is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. There we go. So if I wanted, oops, every other letter, I'll print alphabet. Now, I want to start at the beginning. I want to go to the end, but I want every other letter. Right? So start is optional, end is optional. I want every other letter. So I should get A, C, E, G, I don't know, whatever that works out to be, right? Oops, not debug. Just run. That looks like every other letter in the alphabet. Super weird looking, but you can. And then maybe we want to print out. So if I want all the other, every other letters, right, I could start at 1, end is optional, start by 2. At the end of this, I need to print just a nothing. So here's every other letter, and here's every other letter starting at B. Sure. So if we wanted to smush those two together and kind of jumble our alphabet, we could, right? That works out. If you wanted to stack one after the other.
What is it? Well, for
What is what?
well,
The colon?
yeah.
So this is the start index. We're defaulting to the beginning. The end index, we're defaulting to the end. And then our stride is 2. So the start index, colon, end index, colon, stride.
Uh, like the range stuff.
Yeah. Yep, like you can range by this amount here. Yep. So if you wanted to come up with like a really simple way to encode a message, now encrypt is the wrong word for it, but encode a message, right? We could say, hey, here's I don't know, some message or message is equal to an input of enter a message to code, and then we can print out message sliced by 2, and then we want to just concatenate here, right? So message starting at 1, sliced by 2, right? So if we were to run, oh, I just wanted to select, that's fine. Happy Monday. We get every other letter followed by every other letter. So this is a pretty quick way to scramble it or encode it, right? If you give this to somebody, they could, you tell them, hey, it's every other letter to start and then every other letter after that. Like we could put this back together, right? Might take a little bit here, but you add in your blanks. Yeah.
Well, I said it's the one that I found money and there's a space between the happen like it's the whole space.
Yeah, the space is right here because it ended up in the second half because it was H, P, Y, capital M, N, A. Right. So this was the first half. And the second half was A, P, space, O, T, Y. And so putting this back together is actually a little trickier, right? We can though. So we can say, how about, I don't know, first half is equal to this one here. And then the second half is equal to this one here. Right, so to put it back together, I want to say for index in range length of the first half, I want to print the first half, index of index, change the ending character. And I want to print the second half, index of index, change the ending character. And when I'm done, print a new line. Right? So if we go through both halves and say print the first one of the first half, print the first one of the second half, and then up by 1. Print the second one of the first half, print the second one of the second half, and then up by 2. Right? We can put it back together this way. So we just run this one. We had Happy Monday. Where's it? There it goes. Happy Monday. And we put it back together. Right? So we can unencode or decode. There we go. That's probably the more proper term there. right? So slicing lets you do lots of fun things, right? You can take chunks of strings at a time, any size, right? Depending on what we want to do, right? Maybe we want to divide it by spaces. So if I were to enter my name, maybe we want to divide all those by spaces, and maybe we write a function for. This is actually kind of a silly function, but we can print in title case. How do we do that? So we'll define print in title case given a word, right? And this can be our function here. Now instead of name, it's word, right? So we title case. We give it the first letter, right? Or is that title casing? I don't know. It sounds like it is. Or is that every word gets capitalized, right? I think so. That's fine. So we could say if I want to split this whatever you've entered by spaces, we can do that. So we can remember you can find a given character in a string. You can get the index of a given character in a string. So I could say, space index of space is name.index of space. Right, this index function returns the lowest index in the string where the substring is found, such that the substring is contained within S of start and end. Optional arguments start and end are interpreted as in slice notation. It raises a value error when the substring is not found. Oh, goodness. It'll give me a value error, so it's going to crash on me? That's no fun. We don't actually want it to crash. Let's see. I don't want it to crash. Can we do, say, if name.find space? What's find do for us? Find. Okay, so find is what we want. So find returns the index, but it gives me a -1 when it can't find it. So this one is better. It's not going to give a value. It's not going to crash on us. So we can say find a space, and you can give it optional start and ends. So I can say, what do we want here? The int start index is 0, and while name.find a space, and I want to give it my start index. So start index, there we go. So while we can find a space, right, from a given start index, and what this is not -1. There we go. As long as we don't get a -1 back, I know that there must be a space, at least starting where the start index is. So I want to slice. So I'm going to take the I don't know the word here then will equal my name at the index of start index colon up to name.find a space. Right? That should give me the word out. So starting whatever my start index was, going up to this names of find, or maybe we could even have the space index. There we go. Space index is equal to. This is a little prettier here. Going up to the space index. Oh no, no, that's the start index. Shoot, I gotta change that. Start index. So we keep changing where the start index is. Because then the next time we go find, we'll say, hey, start at this given index, go find the next one. So name equals an input, enter your name. We'll get the word, and then maybe we'll call the print in title case for the word.
So what you see is
This one, that's the substring we're trying to find. So it's telling us, hey, the value we've entered is the string for substring. So I'm trying to find the space character in the name value, name variable. So let's give that a run. So if we do, was it John Jingleheimer Smith or something? Isn't that his name? Uh-oh. We broke it. We got an infinite loop. That was no good. Did we get anything printed out? We didn't get anything printed out. Let's see. So the word was the name from start index. Oh, start index to start index. That's no good. So we want to go to start index before we change the start index. There we go. I guess we can't do that. So we'll do start index. Uh, what do we want here? To the first space. I guess we just do space given start index. After we find the word, then we can change the start index. Start index is equal to, okay, we'll call that the space index. Given start index. There we go. This is a little bit nicer here. So find where the next space is, the index of the space. Find a space starting with your start index, where we start at 0, and then go slice from the start index to where the space is. Then we go change the start to say, okay, we found a space. Next time we go check, start where that space was. Right? And actually, I think we should do +1, right? Because we want to find the next space. And then we can print our word. I think this will work a little nicer for us. John Jingleheimer Smith. Uh-oh. Let's see. So start index. Oh, okay. So we got John Jingleheimer. We confused something here. Oh, we never got the last one. So once it's done, we never printed the last one. That's what it is. So when this loop is done and doesn't find any more, then we can print one last one here. That's a little annoying, I guess. Sure, why not? So when this loop is done, like I got the first name, I got the middle name, and then from here it didn't find another space. So I got back a -1, but we want to print the last name as well. So let's do from the start index to the end, and then we'll print that. Right, colon to the end. So once there are no more spaces left, print the last one here. So the loop ends when no more spaces found, print the last name. And we can run it in debug mode. It might be easier to watch in debug mode here. So let's debug this. So was it John Jacob Jingleheimer Smith? Smith. Okay. So we have our name should have 4 names that we find, right? So our start index is 0. And let's step. So the space index, the first space was found at index 4. So we're going to slice from 0 to 4. We get John. Now my start index goes up now to 5, because the next time we look for it, we want to start in at index 5, which is the J for Jacob. We print that one out. And now we find the next space at index 10 between Jacob and Jingleheimer. And we print Jacob. And we find another space at index 23. We get Jingleheimer. Print that one off. Now, when I go find starting at index 24, there are no more spaces. So now I just want what that start index is to the end for Smith here. And then I can print out Smith in title case. All right. That was very exciting, a way to print that out in title case. Now, you might also know if you've had any fun here, if you said name dot and you looked at all the things you can do, you can title case it already. Python knows how to do this for you. Like, you can just print it out, name and title case, and save yourself the hassle if you really want. John Jacob Jingleheimer Smith. And you get it all title cased already. Python's fun like that. But if you wanted to do it by hand and practice your substrings, because that's the whole point, right? We're practicing our substrings, right? We can find chunks and go through chunks and find more chunks and go through chunks and find more chunks. Figure it out that way. Pretty similarly. Does that make a little bit of sense? That was a lot. We were having some fun with it. Um, I would like to imagine I make these mistakes on purpose, because that's probably what happens when you guys write code. You have an idea and it doesn't work, and then you have to fix it, and then you have to fix it again, fix it again. I'm definitely demonstrating that on purpose, and that's why I do like to code live. rather than just give you a PowerPoint. Because honestly, I think like watching people make mistakes and fix them is worthwhile. So um, I know it makes me look like a little bit of an idiot. I'm okay. I'll live with it. It's okay. Uh, we'll figure it out. All right. So that's straight. That's slicing, doing our strides. Other fun things we can do with our strings, aside just printing, right? I think you've done some of this with the Zybook Xylabs. You had to print very specific things. You can specify a specific width if you want here. So you always have 16 characters. Sure, why not? As we're printing these things out. So that way you can have a nicely formatted output every single time if you want here. Um, you can align characters. This just gets crazy here, but you can with left aligned or right aligned, right? With setting the size here with the left or the right arrow, right? We'll align them a certain way. You can center align with the caret here. It's just some fun output operators to make your text look pretty. I won't ask you to do those. Xylabs will. Uh, I'm not very big on pretty. I'm more big on functional. So that's just, my preference here. There's nothing wrong with pretty, and pretty is actually better. But I'm assuming if you can make it work, we can spend a little bit of time to make it pretty after the fact. That's not really worth a whole lot of time focusing on just to make it look nice. But you'll try it with Xylabs. So, like, you can use pads too. You can say, hey, fill with zeros. Sure. I think we had to do one of these one time, right? I tried to do the fills for the time and then to look that up. And we said, hey, here's all the possible times on a 24-hour clock. So that's super exciting. And then rounding, right? Point 2F. This one's fun to round when you output things with point 2F. Right. Other things you can do with strings, you can replace an old string with a new string. Remember, strings are immutable. So if you change something, you have to save it as a new string if you want to keep that new result. So that's why it's phase.replace, phrase.replace, right? Phrase is equal to, we're assigning a new value of this being replaced, this being replaced, this being replaced, this being replaced, this being replaced. So we can change all of our 1 through 9s to Spanish with a bunch of different replaces here. And you can translate them here. So we did find. I got ahead of myself. We can find here. You can find from a start, you can find to an end. You can reverse find, going from the right-hand side to the left. You can count how many times a character shows up. You can check to see if it's in with our substrings. Is this string in another string here? You got lots of fun options here. And look at that. String searching example given hangman. This is not the same way that our hangman works, right? Our hangman uses very specific functions, right? Not the same thing as this, right? We're not putting dashes in our hidden word because they're actually like replacing as they go in the hidden word, right? They'll go and replace with the hidden word. And this to me actually seems really awkward, right? We've done some string slicing, but they said, okay, for the number of occurrences in the range number of occurrences, right? They count how many times that character was in the word. Then they go and find that position, and then they reslice the word to put it back together because their hidden word has a bunch of dashes in it. That seems like a lot of work for me. I I, I don't know. Like I don't like this approach, but they're just demonstrating with string slicing here, right? I think our approach will be a little easier. But again, that's me. So um, you can compare strings, weirdly or not, right? We've done equals, we've done not equals, but you can ask if a string is greater than or less than another string. Sure, because remember, every character has that ordinal value, the ASCII value or Unicode value. So a capital A is less than a capital Y because A has a lower Unicode value than a capital Y does. Now, it's not very useful, but it actually is used when we sort strings. When we sort, because you can numerically compare them like that, you can sort them alphabetically by less than, greater than, really quickly. So it's kind of fun, I guess, if you have a bunch of strings, sort out the smallest string, which is the least string, right? Sure, you can sort. Um, this identity operator is super weird here. So is checks to see if they are the same object in memory. So if you enter a value here, it's going to store that somewhere in memory. If you say if it is just a hard-coded string, this string is not stored in memory where this one is stored in memory. So you're going to get false. So is the wrong operator to use. We don't get to is for quite a while. So just pretend like it doesn't exist for a while, okay? It'll just make life easier. We use the equality operator. Some fun things you can do with strings. You can check if it's alphanumeric, if it's a digit, if it's lowercase, if it's uppercase, if it's a space, if it starts with, or if it ends with something. Sure, any and everything. So do you want to see if your connection is secure or not? HTTPS versus HTTP, right? Your connection using secure HTTP. You can check to see if it starts with that. Sure, why not? You can make new strings, right? This idea strings are immutable, so capitalize gives a copy of the string with the first character capitalized. Lower, upper. Strip is really useful because it gets rid of any leading and ending trailing white space. So sometimes the users hit space when we don't expect them to. If you want to strip out all the spaces, all the white space, you can use strip. That's handy for dealing with input. Yeah.
Can you use more than one method?
Yep.
The symphony?
Yep. Yeah, just kind of like chain them all together. Um, yep. And we did title casing, we found that one. So like input.strip.lower takes out all the spaces and then lowercase is everything. So whether or not they entered Bob, Bob with the space, lowercase Bob, they'll all turn into Bob, lowercase, which makes it easier for me to compare later on, right? So in your passenger database, right, you can uppercase and lowercase and check all of these things out to make sure that they're all standardized when we do our input or when we're storing the values. Especially when we start using dictionaries, right? And you check for the key of a string, right? Capital E Eric is not the same as lowercase e Eric. Eric with a space is not the same as Eric with no space. Right? So it gets to be very specific when we're looking up strings. So standardizing somehow with like strip and lower is pretty common. We haven't really bothered with strip very much because we don't expect our users to enter lots of spaces, but you get some weird things, uh, especially when we start dealing with input in files. Files have all sorts of weird stuff too. So stripping is kind of handy for that. All right, and then the last string piece here, we did it the hard way. You can actually split a string automatically. We don't need to find the first index of something and then take a slice and then find the next index starting at that and then take a slice. You can just call split. So I can come back into Python here and I can say, let's do for, well, what do I call it? Single name or something. I don't know, in name.split. And what do you want to split? I want to split where there's a space. So then I can print in title case, oops, print in title case single name. We should just say word. We'll call that word. So splitting on a space will take this, and every time it finds a space, will turn it into a separate string for me. So let me put a breakpoint here and debug this. So is it John, Jacob, Jingleheimer, Smith? So the first word is John, right? It automatically found the space, got me a substring of that one. Now my word is Jacob, right? It found the next space and gave me the things between the spaces. Found the next one, found the next one. So this is the fast way to split things. You don't have to do it yourself this way. It basically does this behind the scenes, but we have the split function written for us in the Python library. Super handy. So you can split all sorts of things based on whatever sort of character. You can use the pound sign, you can use any sort of delimiter. Whatever you want to say is a delimiter here, you can split on. Now, if you've done any work in Excel, you might be familiar with comma separated value files, CSV files, where everything is separated by commas. So maybe you wanted to split your data out by commas. That could work. The downside of that is if you have a comma in your data, it gets really confused really quick. Because if you're splitting on a comma, now you're going to start splitting your fields, and that gets really ugly. So then fields have to be quoted, and then you have to deal with quotes separately, and it's a whole bunch of nonsense. Turns out there's a library to work with CSV files. Who knew? But you just got to be careful with it. So splitting, like if you wanted to split your URL on slashes here, you can split your URL on slashes and have Wikipedia, Wiki, Ethernet. Sure, that's my URL. Or HTTP Now I get a blank one here because there was nothing between those two slashes. Sure. So you can do lots of fun with splitting. The opposite of splitting is joining. Joining takes a character, puts it in between all the things in a list. That one, there's certain cases where it's really handy, and other times it's just really weird. So if I wanted to give you a bunch of, uh, let's see, so let me give you a bunch of numbers here. So if I have, numbers is 1, 2, 3, 4, 5. Oh, we'll do names. We'll do names. So this is names. So we have Joy, Jeb, Phoebe, Journey. So my kids' names: Jubilee, Jack, and Jasper. So here's a list of names. If I want to put them all together with a specific delimiter, I can say, hey, let's take maybe the comma here, and we'll call join names. So it's going to take all the names and put a comma and a space in between them all. So then we can print that. And if I just run that one, we get comma separated names because they're separated by a comma and a space now. It joins the list together with whatever you want in between them, which is nice because it doesn't do the end one at the end. Right? I don't have to. I could just do a loop, right? You might think, hey, we could say for name in names. Let's print the name and then an actual comma here. Right? I'm going to get the last trailing comma here with this version. Oops, we could change that ending character. And there you go. So they're all one line here. There you go. But now there's a comma at the end of Jasper because every one of them prints the last one here, prints a comma. And now that looks really weird. Oops, name plus a comma. There we go. Comma and a space. We'll get it real close here. There we go. So it looks almost identical, but now I have that ending one. So doing it by hand is harder, right, than just using the join. Join's a little funny though. It's gonna be weird. Um, we don't use it all the time, but occasionally join's really handy when we're doing this sort of thing.
Well, like, that's a
Yeah, concatenates them all together with this in between them all. Yeah, we'll just concatenate, take everything in the list, switch them all together. Yep. Um, like, I don't know why you'd want. They're just showing you it could be a loop. Yeah, it could be a loop, could be that. Uh, Using split and join together, sure. Um, in Macland, you use forward slashes. In Linux, you use forward slashes in your path. In Windows land, we use backslashes to say where our files are. Right? If you look at the path for a file, you go open up this one here. Open in Explorer. I click on my path here, right? You see I use backslashes here in Windows land. So if I wanted to change this to a Mac path, I could replace every backslash with a forward slash. Sure, and then just kind of split and rejoin real quickly. You can change your delimiters if you want. Um, there's some fun ones. That's actually the whole string chapter. So it's not the biggest one. So we've got a little extra time. Is that okay? All right, so we can go work on Hangman. I don't think you need any of these string methods for Hangman, right? The membership operator, we said, is this string in another string? Is about the only one we need because that will check things very easily for us, right? Is a given string or character in another string? That's probably the quickest one for you with that membership operator, the in operator. You can use all these ones. You can use find if you want. Go for it. But I don't think you need to, and you shouldn't have to do any slicing as well either. We're just using loops. We're using um, that membership operator with functions. All right, so we'll do our lab at 2 o'clock. We'll practice some more of these string things. Should be a relatively quick lab. Let's do a couple of these, have a little fun with them, and then we'll call it a day. So Wednesday, we don't have anything new. Shoot. What should we do Wednesday? We might start on lists because lists and dictionaries is kind of a big chapter. So maybe we'll start on lists on Wednesday. Is that okay? We'll move this up just a little bit. Okay. We'll bump that lists up a little bit so we can talk about that on Wednesday. All right. Awesome. So I'll see you guys at 2 o'clock for lab. That'll be fun.